So guys, we are now, this is the last video. We saw how to solve differential equation initial value problem using Laplace transform. I'm gonna discuss more properties of Laplace transform. The first one is about convolutions. The thing is, you know that the Laplace transform of f times g is not equal to the Laplace transform of f times the Laplace transform of g. For example, you know that the Laplace transform of 1, or the Laplace transform of t, for example, is n factorial, so t power 1 factorial over s square. So this is 1 over s square. And the Laplace transform of 1 equal 1 over s. So the Laplace transform of 1 times t is equal to the Laplace transform of t, yes? 1 times t is equal to t, is equal 1 over s squared. But the Laplace transform of 1 times the Laplace transform of t is equal to 1 over s cubed. So you see these are different. So the thing is, we are looking for an operation between f and g, so that the Laplace transform of f times g will be equal to Laplace transform of f times Laplace transform of g. And this is not the product. So the definition, so given f and g piecewise continuous functions on 0 infinity, we define the convolution f, so it's an asterisk g at x is equal to integral from 0 to t, so sorry, f convolves g at t, because I'm talking about time, of f of tau g of t minus tau d tau. So this is an integral with respect to tau, okay? And then this will give you a function for each t, this integral will be different. So as an example, what is 1 convolved with t? So this will be equal integral from 0 to t. So here f of t equal to 1, g of t equal t. So this is equal to f of t, which is f of tau. So f of t is 1, f of tau is 1, times t minus tau d tau. So this will be equal to integral from 0 to t of t minus tau d tau. And remember, I'm integrating with respect to t. I'm integrating with respect to tau. So this will be, so t is like a constant. So this is t tau minus tau squared over 2 from tau equals 0 to tau equal t. And this is equal t squared minus t squared over 2, which is equal to t squared over 2. But notice now, what is the Laplace of t squared over 2? This is equal 1/2 the Laplace, so notice, 1/2 the Laplace of t squared, which is 1/2 times 2 factorial over t cubed, which is equal 1 over t cubed. And what is, so this is t squared over 2, this is the Laplace of 1, this thing is equal 1 convolves with t. And what is the Laplace of 1 times the Laplace of t? This is equal, as we saw up, 1 over s times 1 over s squared, 2 over s cubed, 2 over s cubed. And this is equal 1 over s cubed. So notice that the Laplace of 1 convolves with t, or we call it t1 convolves with t, is equal to the Laplace of 1 times the Laplace of t. Now, is this a coincidence? Because this is an example. Who said that this is true in general? Is it a coincidence? And the answer is no. So proposition, so no. And now you have proposition. Assume f of s equals the Laplace of f of t, and g of s equals the Laplace of g of t, and both exist for s larger than a. Then the Laplace of f convolves with g equals the Laplace of f times the Laplace of g equal f of s times g of s. Okay. So proof. What by definition is Laplace of f convolves with g at t? This is equal at s, sorry. This is equal integral from 0 to infinity by definition of f convolves with g at t e to the minus st dt. But now this is equal integral from 0 to infinity. By definition, what's f convolved with g? It's integral from 0 to t of f of tau g of t minus tau times e to the minus st, d tau e to the minus st dt. So this is equal integral from 0 to infinity, integral from 0 to t of f of tau g of t minus tau e to the minus st d tau dt. Now I want to switch the order of integration. So when I'm integrating, if this is tau, and well, if this is t, let's say, and this is tau, I'm integrating. If I draw a line parallel to, well, maybe this is t easier. This is t, and this is tau. So d tau means I draw a line parallel to the tau axis. It will enter my region at tau equals 0, which is here, and it will leave my region at tau equal t, which is here. So this is tau equal t, and I have t is between 0 and infinity, so this is my region. So switch the order of integration. This will be equal. Now let's do it dt d tau. So this is Fubini's theorem, f of t g of t minus tau e to the minus st dt d tau. So draw a line parallel to the t-axis. It will enter my region at t equal tau, and then go to infinity. And my tau is between 0 and infinity. Okay? But notice now that f does not depend on t. F of tau does not depend on t. So this will be integral from 0 to infinity of f of tau times integral from tau to infinity of g of t minus tau e to the minus st dt times d tau. Okay, and now this is equal. Let's use the change of variable z equal t minus tau. So you will get dz equal dt. This is in the inner integral. So it will be 0 to infinity times when t equal tau, z will be 0, and when t goes to infinity, z will go to infinity. G of t minus tau is z, e to the minus s. What is t? T is z plus tau, and now this is dt, and all this here, I remember I have f of tau, and this is d tau. So this will be equal integral from 0 to infinity. Notice that this thing here is equal to e to the minus sz times e to the minus, this is dz, e to the minus s tau. But the e to the minus s tau does not depend on z, so this will be f of tau e to the minus s tau times integral from 0 to infinity g of z e to the minus sz dz, and the whole thing d tau. But now this is what? This is g of s. That does not depend on tau. So I put it, this is g of s integral from 0 to infinity f of tau e to the minus s tau d tau. And this is nothing here but f of s. So this is f of s g of s. And this is the Laplace transform of f convolved with g. Very important identity. Now as a corollary, what is the Laplace transform of integral from 0 to t of f of tau d tau? And you will find that this is f of s over s. This is a property that is in your Laplace table. So proof, let g of t to be equal to 1. So what is f convolved with g at t? This is equal integral from 0 to t of f of tau g of t minus tau dt. But g is equal to 1 for all t, so this is equal integral from 0 to t of f of d tau. F of tau d tau, this is f convolved with g at t. But the Laplace of f convolved with g is equal to the Laplace of f times Laplace of g, which is f of s times the Laplace of 1, which is f of s times 1 over s. And this implies that the Laplace f convolved with g is nothing but this integral. So this is f of tau d tau equal f of s over s. So if you want to calculate the Laplace of an antiderivative that vanish at 0, this will be f of s over s. I will do a couple of examples. Well, I will do 4 examples, in fact, I think. But let's start with an easy one. Example. What is the Laplace inverse of 1 over s times s squared plus 4? Okay. Method 1, which is a good method, by the way. 1 over s times s squared plus 4 is equal a over s plus b s plus c over s squared plus 4. Now multiply by s times s squared plus 4 both sides, so you get 1 equal a times s squared plus 4 plus bs plus c times s. And this is 1 equal a plus b s squared plus cs plus 4a. So you get a plus b equal to 0, c equal to 0, and 4a equal to 1. So you get a equal 1 over 4, b equal minus 1 over 4, and c equal to 0. And this implies that 1 over s times s squared plus 4 is equal 1 over 4 over s minus 1 over 4 s over s squared plus 4. Now you know that 1, if you apply Laplace, you get 1 over s, and you know that cosine 2t, if you apply Laplace transform, you get s over s squared plus 4. So you conclude that the Laplace inverse of 1 over s times s squared plus 4 is equal 1 over 4 minus 1 over 4 cosine 2t. Okay. Now another method, method 2, which is also a good idea. You have 1 over s times s squared plus 4 equal 1 over s squared plus 4 over s. Okay, so let's write this as g of s over s, where g of s is equal 1 over s squared plus 4. So I know that the Laplace inverse of 1 over s of g of s over s is equal integral from 0 to t of g of tau d tau. Yes, this is a property here, where g of t is a Laplace inverse of 1 over s squared plus 4. But you know that 2 over s squared plus 4 is a Laplace of sine 2t. This implies that g of t is equal 1 over 2 sine 2t. And this implies that the Laplace inverse of 1 over s squared plus 4 over s is integral from 0 to t of 1 over 2 sine 2 tau d tau. And this is equal 1 over 2 into minus cosine 2 tau over 2, where tau between 0 and t. And this will be equal 1 over 4 into minus cosine 2t plus 1 equal 1 over 4 minus 1 over 4 cosine 2t. See, both works, both are fine. Okay. Now, example 2. And for example 2, you need the following hint. So recall that sine a sine b is equal half cosine a minus b minus cosine a plus b. Okay, so question 1 is A, find Laplace inverse of 1 over s squared plus 9 squared, and B, conclude the solution of the following IVP: y double prime plus 9y equals sine 3t, where y of 0 equal to 0 and y prime of 0 equal to 1. Notice, guys, this is like the spring model system, where the frequency is 3, which is the same as the natural frequency. So I expect resonance here. Okay. Now let's solve. Okay, solution. Okay. Now 1 over s squared plus 9 squared, this is not in the table. Okay. But you can notice that this is, this is 1 over s squared plus 9 times 1 over s squared plus 9. And I know that sine 3t, the Laplace transform of sine 3t is 3 over s squared plus 9. So this means that 1 over s squared plus 9 is equal 1 over 9 times 3 over s squared plus 9 times 3 over s squared plus 9. So 1 over s squared plus 9 equal 1 over 9 the Laplace of sine 3t times the Laplace of sine 3t. And this implies that the Laplace inverse of 1 over s squared plus 9 is equal 1 over 9 times the convolution of sine 3t with sine 3t. And now I need to calculate the convolution. This is equal 1 over 9 integral from 0 to t sine 3 tau sine 3t minus tau d tau. And now I use that sine a, the identity here. Sine a sine b is half cosine a minus b minus cosine a plus b. So this is 0 to t sine of 3 tau plus 3t minus, of minus 3t plus 3 tau minus sine 3 tau plus 3t minus 3 tau. And this is d tau. And this is equal 1 over 9 integral from 0 to t sine 6 tau minus 3t minus sine 3t d tau. And remember, I'm integrating respect to tau, so t is like a constant inside. So this is 1 over 9. What is the integral of sine 6 tau minus 3t? This is minus cosine respect to tau, 6 tau minus 3t over 6 minus tau sine 3t. And this is from tau equals 0 to tau equal t. So this is 1 over 9. Guys, this is... Okay, I used the wrong identity. This is cosine here. Cosine. Cosine and cosine. Okay, so let's redo this slowly. So sine A sine B is cosine A minus B minus cosine A plus B. So this is cosine 6 tau minus cosine 3t. Now, the integral of cosine is sine, and here this is just a constant with respect to tau, so this is tau cosine 3t. So this is 1 over 9. Now replace t by tau by t, so you get sine 3t over 6, 6t minus 3t, so sine 3t over 6 minus, when tau equals 0, this will be sine minus 3t over 6. Okay. And minus, replace tau by t, minus t cosine 3t, plus when tau equals 0, this will be 0. Remember, the sine of minus alpha is minus sine alpha, so this is 1 over 9 times 2 sine 3t over 6 minus t cosine 3t. And this is equal, 2 over 6 is 1 over 3, so this is 1 over 27 sine 3t minus 1 over 9 t cosine 3t. Correct? 3. Again, I'm not sure why I'm keep doing the same mistakes here. You have a half here. I'm so sorry for the confusion. Okay, so this is over 2. This is over 2. So this will be 18. This will be 18. This will be 18. Okay. So this will be 2 over 18. So this is sine 3t over 54 minus 1 over 18 times t cosine 3t. And now the question is to solve. So part B, we have to solve the differential equation y double prime plus 9y equals sine 3t, y of 0 equals 0, y prime of 0 equal to 1. Okay, so you have to apply Laplace transform. So applying Laplace transform, let y of s be the Laplace transform of y of t. Then what is the Laplace transform of y second? It will s square y of s minus s y of 0 minus y prime of 0. And this is equal to s square y of s minus 1. And what is the Laplace of sine 3t? This is 3 over s square plus 9. Okay? And then we get, so replace in the ODE. You have y second, so this is s square ys minus 1 minus 9 ys is equal to 3 over s squared plus 9. And then you get s squared you have plus 9s. So s squared plus 9 y of s equals 3 over s squared plus 9 plus 1. So y of s equals 3 over s squared plus 9 squared plus 1 over s squared plus 9. So this implies that y of t equals 3 Laplace inverse of 1 over s squared plus 9 squared plus Laplace inverse of 1 over s squared plus 9. And I just calculated this, so this is 3. The Laplace inverse is sine 3t over 54 minus t cosine 3t over 9 minus t cosine 3t over 18. And the Laplace inverse of 1 over s squared plus 9 is equal 1 over 3 sine 3t. So you get sine 3t over 18 plus sine 3t over 3. So 1 over 3 plus 1 over 18 sine 3t minus t cosine 3t over 18. Okay. I mean 1, then 6, 7 here. 3 over 54 is 1. 54 divided by 3 is 1. 18. Yes, this is correct. So this is 18, and you have a 18 and 1 over 3. Okay, which is over 18 is 7 over 18 sine 3t minus t cosine 3t over 18. Okay. And this is the resonance due to the t cosine 3t. Now another example, you can solve now a new type of equation, example. These are called Volterra differential equation or Volterra integral equation. So the question is to solve f of t plus integral from 0 to t f of t minus tau e to the minus 6 tau d tau equal e to the t times u of t minus 2. So if I want to write this in another way, so this is f of t plus e to the minus 6t convolved with f equal e to the t ut minus 2. Remember, I want to use that e to the t minus f of t minus a u of t minus a. I can write this as e to the 2 times e to the t minus 2 u of t minus 2. Now let f of s be equal to the Laplace transform of f. Let's see. I know that, so I know f goes to the Laplace transform is big F. What about e to the minus 6t convolves with f? This will be the Laplace transform of e to the minus 6t. I'm sorry. So what is e to the minus 6t? If you apply Laplace transform, this will be 1 over s plus 6. So this implies that e to the minus 6t convolves with f. If you apply Laplace transform, it will be f of s over s plus 6, or f of s times 1 over s plus 6. And what is the Laplace transform of e to the t? This is because now I still have this. It's 1 over s minus 1. So what's the Laplace transform of e to the t minus 2 u of t minus 2? This will be e to the minus 2s over s minus 1. This is a shift property. Okay. So this implies, so f of t here becomes f of s plus f of s over s plus 6. This is equal e squared times e to the minus 2s over s minus 1. Okay. So let's see. So this is f of s times, let's do s plus 6. You will get s plus 7 because s plus 6 plus 1, s plus 7 of s plus 6 equal e squared e to the minus 2s over s minus 1. So f of s equal e squared e to the minus 2s times s plus 6 over s plus 7 over s minus 1, which I will call it big G of s. So you know that if g of t is the Laplace transform, if Laplace transform of g of t equal g of s, then you deduce that little f of t is e squared. You have e to the minus 2s. So you have f of s equal e squared e to the minus 2s g of s. So f of t will be e squared times g of t minus a, which is g of t minus 2 u of t minus 2. This is a shift property. And this is what is expected. So I need to find the g, little g of t. So need to find g of t, which is the Laplace inverse of s plus 6 over s plus 7 times s minus 1. So here I have to use partial fraction. S plus 6 over s plus 7 times s minus 1. This is equal a over s plus 7 plus b over s minus 1. So this is s plus 6 equal a times s minus 1 cross multiply plus b times s plus 7. Now take s to be 1. You get 7 equal 8b. So b equal 7 over 8. So I took s plus 6 equal a times s minus 1 times s plus 7. Take s to be 1. So we get b equals 7 over 8. And take s to be minus 7. Oh, yes, this is true. Take s to be minus 7, you get minus 1 equal minus 8a. So a equal 1 over 8. So s plus 6 over s plus 7 times s minus 1 is equal 1 over 8 times 1 over s plus 7 plus 7 over 8 times 1 over s minus 1. And then g of t, which is the Laplace inverse of 1 over 8 times 1 over s plus 7 plus 7 over 8 times 1 over s minus 1. This is equal 1 over 8 e to the minus 7t plus 7 over 8 times e to the t. And this implies f of t, remember, is e squared g of t minus 2 u of t minus 2. And this is equal e squared times 1 over 8 e to the minus 7 t minus 2 plus 7 over 8 e to the t minus 2 u of t minus 2. Which, if you want to write correctly, this is equal, if t is smaller than 2, this is 0. And if t is larger than 2, this is e squared over 8 e to the e squared over 8 e to the minus 7 t minus 2. Well, you can put the e to the power well, fine. No, don't do anything. The plus 7 e to the t minus 2. Okay. What I meant is you can write this as 1 over 8 e to the minus 7t plus 14 plus 16 plus 7 e to the t. Okay. And that's the end of this chapter. Okay. You can solve integer differential equation, and you can using convolution, and you can calculate also some Laplace transform using convolution. You will still have one section which is about the Dirac delta function.